Why do some materials, when cooled to a certain temperature, suddenly drop their electrical resistance to zero, as if a switch is flipped? In the energy filament theory, this isn't magic, it's a rare reversal of the usual dynamic. Instead of the field commanding the particles themselves group together and lock the field's behavior within the material. Let's start with regular metals. Imagine electrons as a group of people moving in different directions on an uneven surface. Some collide with atomic grid points, some are pulled by impurities, and others bump into each other. When an electric field is applied, it's like shouting, "Move this way." On a slope the particles move, but they keep hitting obstacles, falling into pits, and making turns. The energy C forms countless small fluctuations, creating resistance and heat. Now, in the superconducting state, everything changes. At extremely low temperatures, the electrons calm down and pair up, moving together in a unified flow, no longer going their separate ways, but most of them synchronized to follow the same rhythm, traveling in a loop. Essentially, they create a large, organized near-field texture in the energy C, like forming a synchronized electron choir within the material. At this point, the field's behavior isn't free anymore. When the electric field tries to move in the material, it finds that all the chaotic motions are blocked by the organized texture. The only remaining allowed action is to move the entire choir together. The energy C has no place for small fluctuations, and the usual scattering, friction, and heat dissipation paths are shut off. As a result, the electric current can flow endlessly without finding a path to convert energy into heat. This is zero resistance. Superfluidity works similarly, but with atoms instead of electrons. In regular liquids, atoms move randomly, and when a field is applied, they drag each other, losing energy. In the superfluid state, many atoms lock into a single flow pattern, and the entire liquid glides smoothly through the energy C. In this case, the field only has a global push, and there's almost no friction. To sum it up, in regular materials, the field controls how the particles move. In superconductors and superfluids, the macroscopic structure takes charge. Large groups of particles form a unified pattern that dictates the field's behavior, leading to zero resistance and zero viscosity. This is the fresh, vivid picture the energy filament theory offers behind zero resistance and superfluidity. Tap follow, share it on New Physics, Clear Universe.